it is very undeniable that machine learning is very popular nowadays, and it's been gaining a lot of attention from the government and from the business sectors. So machine learning is very important in operations for businesses and for the delivery of social services on the part of the government. So it has been used to optimize business operations, and also it has been used to optimize the delivery of basic services to the people, that is with respect to the government agencies. And it is also used to anticipate whatever the demands of the customer would be, because machine learning is used to understand the different patterns of customer behavior. Okay, so with that, machine learning has different, of course, categories. We know that it could be unsupervised, it could be supervised, and it could be reinforcement learning. And these different categories, these different algorithms are used in different functions or different purposes. So, for example, for supervised learning, we have classification, which is used to understand the customer retention. It is also used to classify images. And for unsupervised learning, we have dimensionality reduction. It is very useful if we would like to have a meaningful compression, to have a discovery of a certain structure of a certain data. And for reinforcement learning, we use that for skill acquisition, for robot navigation, for game AI. So I would like to share with you the situations nowadays when it comes to machine learning. When I say situation, it has something to do with the demand and how the different businesses around the world, especially multinational companies, have been putting a lot or a big chunk of their investments in machine learning. So the global machine learning market was valued at 1.58 billion US dollars, and that was in 2017. And it is expected to reach $20.83 billion in 2024, and that's really a lot of money. And to sum it all, it grows at a rate of 44.06% between 2017 to 2024. And when I say growth here, it has something to do with the compound annual growth rate. Also, it is projected to grow at a compound annual growth rate of 42.8% from 2018 to 2024. The global machine learning market will be worth $30.6 billion in 4 years. That's really a lot of money. And according to Tractica, the annual global AI software revenue will grow from 10.1 billion to $126 billion by 2025, achieving a compound annual growth rate of 43.41%. That's really a lot now. So with this great amount of money involved, with this huge investment and huge growth of machine learning, it's really very important for us, for you and me, to really take part in this growth. And how to do that? We're going to understand how to use machine learning effectively, because a lot of companies have been struggling for this. Okay, so before we go to different tips, let me first share with you the findings of Stanford University's Institute for Human-Centered Artificial Intelligence. So according to this study, the global machine learning market is projected to grow from $7.3 billion in 2020 to $30.6 billion in 2024, and that is attaining a compound annual growth rate of 43%. And also, 1 in 10 enterprises now use 10 or more AI applications like chatbot processes or process optimization and fraud analysis. And this lead a recent survey's top use cases. So the prevalent applications include the consumer market segmentation and also the computer assisted diagnostics. And according to this study, 83% of IT leaders say that AI and machine learning is transforming customer engagement, and 69% say it is transforming their business. See? So with this, we can really say that artificial intelligence, which is centered in the human-centered artificial intelligence, is really gaining momentum. So if we're going to look at this graph on the left side, we could see that the machine learning applications is having or has a big chunk of investments at 28.5 billion US dollars. So taking note of this, advances and growth of human-centered artificial intelligence and machine learning, then the problem is that many organizations, it could be government, it could be non-profit organizations, and even profit organizations, still struggle how to use machine learning. And because they struggle how to use machine learning and how to maximize the benefits they can derive from them, they lag behind as a result. Okay, so now let's go to the different tips on how to effectively use machine learning for the maximization of its benefits. Let's have the first one. We have first to look at the data. So data, or looking at the data, is really very important, because without you understanding the nature of the data, the form of the data, it would be very difficult for you to go to the next step. It's okay. So remember this that data, raw data to be more specific, is not clean. So because it's not clean, and when you process that to find the result would be distorted. Okay, so what you will do in this part is that you're going to look for the outliers. And maybe you would like to ask me, after identifying these outliers, are we going to just throw or delete these outliers? What are we going to do with them? Okay, now this is the situation. This is the thing that you have to take note of. Outlier may not be good for use for a certain process for the meantime, but then you can just um, separate it for a different use, because this outlier may tell you or may describe a different pattern which can be used also, and that can be used for your own benefit. But for understanding a certain thing for the moment, you have to first segregate that outlier. Okay, so that is really very important before you build your model, that you have to review your data. The next step is that you're going to segment your data. So when we say segmentation, it has something to do with slicing your data, like a pizza here that you could see. So after slicing your data, what are we going to do with the slice, with each slice? So okay, so each slice should have its own model. So build a certain model for each slice. Okay, say for example, you have there a credit rating. So down payment, that is below 500. And then you have another down payment from 500 to 700. Then you have there above 800. Okay, so what are you going to do with that kind of data? So each one has its own nature. So it's different category, different slice, and different slice. So each one must be dealt with accordingly. So each slice of the data should have its own model. Okay, so once you have already identified the target for a certain model, the next thing to do is that you're going to make a decision tree, because this decision tree would be able to tell you a separate model, the separate model for a certain segment. Okay, and also this certain model for a certain segment would give you an idea how to deal with. For example, if you are into marketing, the right marketing strategy, the right packaging of your product, and even the right pricing. Okay. Now, our third tip is that you're going to use a simple model. Okay. So we have so many different machine learning algorithms. It could be supervised, it could be unsupervised, or it could be reinforcement. So under each one, for example, if supervised, we could have regression, which also has its own different categories. We have decision tree, random forest, and classification, and many more. So for unsupervised, you have clustering, association analysis, then you have the hidden Markov model. Okay. Now the question is this: are we going to use all of them? Okay. The one thing that you have to remember is that you're going to always think for simplicity, simple model. Why do we have to think for a simple model? Because first and foremost, simple model is easy to use, and it's easy to be changed later on, and also it's very easy to deploy. So now the question is that, are we going to use a simple model all the time? Of course, the answer is no. Why? Because not all the time a simple model can really answer the question. There are times when a more complex model can really give you better results, better prediction. So you have to really understand first the situation, and you have to also make some kind of adjustments as you go along with the process of deployment of your model. Okay, so now the next tip that you have to always remember is that you're going to identify unusual events. So when we say unusual events, it has something to do with data that is imbalanced. Okay, so when we say imbalanced data, for example, I'm going to give you a certain case. We have 1:100. So in your sales data, for example, 90% of your customers are Americans, and 10%, for example, are Asian. Okay, so with this respect, you could see that there is an imbalance or disproportion of your data. So just imagine 1:90. Okay, so with this, how are we going to deal with this kind of data? So there are two things that we need to think of when we are faced with imbalanced data. We could do undersampling, we could do oversampling. So when we say oversampling, we could duplicate some examples from our minority. So for 20, you can just make it 50. So you can just have it 50 instead of 10. And also we could use oversampling. Okay, what I've said is actually oversampling. Okay, let me repeat that. So for oversampling, what we're going to do is that we're going to duplicate the data for our minority. Okay, so for example, for 10, you're going to make that 50. Okay, that is oversampling. In the case of undersampling, in this case, we're going to delete some entries in our majority of data. So for 90, you can just make it 50. Okay, so in that case, we could see that there is some kind of balance now. Okay, so if you could already have your undersampling and oversampling, the result would be that your training data would be now more biased, and it would give you a better result. Okay, now the next thing that we're going to do is that we're going to combine models. Okay, so of course it's a situation, it's a real situation that data scientists use different forms of algorithms, like for example gradient boosting and random forest, just to automatically build a lot of models. Okay, so But then the problem for building, or I mean for using the gradient boosting or random forest would be that there would be some kind of generalizations, or it could be over generalization to some extent. Okay, why? Because our model puts too much focus on a certain training data. Okay, so when that particular model is applied for a different data set, then it does not learn it. Why? Because the reason is that it puts too much focus on the training data. So let's have this one. For example, you could see there three different values. The first one is underfitted, the second one is good fit or robust, and the third one is overfitted. So in our first entry, we could see that the dots are actually forming a U shape, but then our model is a straight line. Okay, that's a linear model. So based on that, we could see that it does not create a generalization of the data. Okay, though it is very simple, but then it does not generalize. Now let's go to our third one. We could see that it is overfit. Why? Because all the data points are learned. So we could see that there is over generalization of the different points. So the problem with this kind is that when it is applied to a different data set, then it would not be able to learn from it, because the the problem is that uh, it may disregard the different attributes of a new data set because it overfits the training set. Now, if you're going to look at the second one, which is a good fit or robust fit, this is supposed to be, and this is always the kind of model that we're going to use. So as you could see, it does not overfit, it does not underfit. So it learns from the training set, but it does not disregard the future set. I mean the future attributes. I mean the attributes of a future set. Okay, so it is adjustable, and the bias is lesser. Okay, but of course you have to make some kind of adjustment or changes as when you deploy or when you apply this kind of model for a different data set. Okay. Our sixth tip is that you're going to deploy the model. So when you have the model, of course, you're going to deploy. But in so many cases, deployment of your model may take weeks or even months to wait for it to be deployed. And sometimes, and it really happens when your model does not even gets deployed. Okay, now, what you're going to do with that respect, I think the main problem is that when a certain model that you've done is not deployed, is maybe you don't understand the business case. Okay, something is wrong. Okay, but remember this, because data science is not first and foremost about making a model, building a model, but it's about uh, decision making. It's about solving a certain problem. Okay, so first and foremost, you have first to understand what you're dealing with, what business you're dealing with, what kind of problem you are dealing with, what kind of scenario this model is going to solve. Okay, so you have to always do that. And of course, when you have your model, sit with that, you can always access to the data. So it's very important to also work with different IT guys and for the data engineers who are going to make data marts or data storage for you, so that from time to time you can just access the data. And of course, that's very important so that you would be able to make some kind of adjustments. And with that, when you can already access to the data mart, you can have the monitoring of the performance of your model. Okay. Our seventh step is that you're going to tune the model. So when we say tuning, it has something to do with maximizing the performance or maximizing the performance of your model so that you would be able to avoid overfitting and underfitting. Okay, so tuning the model has something to do with understanding what we call hyperparameters. So hyperparameters, these are the things that are not in the data, but are outside in the data, but affect the performance of your model. So say, for example, we have the learning rate. The learning rate is not found in the data, but that is actually made or designed outside. Okay, so you're going to decide that is for you to decide what kind of learning rate you're going to use. And also the data intervals. Is it a monthly? It is daily? It's up to you which one you're going to use. And also the different hidden layers. So what are the hidden layers in your data? So these are some of the hyperparameters that you're going to think of. And for you to be able to test your model or to tune your model, you can use grid search, which is one of the best method in tuning your model. So in grid search, what we do is that we make different combinations. So out of these different combinations of different hyperparameters, we can be able to identify which of these combinations really give the best performance. Next thing is that we're going to oversee the different changes. So we should be able to manage the different changes. So there are features that are used for your data. So when these features are added, then your model is fundamentally changed, and because of that, the result can be changed too. So you have to see these changes. You have to see the different losses, the different errors for certain features to be used. Okay. Then next one is that we're going to stabilize generalization. Okay, so when we say stabilizing our generalization, we have to take note first that bias is always present in our data, and there is no way we can avoid that, because from the very instance of the data collections, human bias can be there. Okay, so for example, when you collect the data, you just favors a certain group of people, certain group of your respondents to answer, but for different group of people, you just disregard them. So that is actually a bias, a blind spot of collecting your data. So what are we going to do here is that we have to think of a way that our model can really make proper generalization and the stabilization of the of the model. So there are two things that you're going to take note of. So if the variance error is high, it's time for you to use more data and even add more subset features. The other thing is that if your bias error is high, then it's time for you to use more features. So using the right evaluation matrix or metric is very important so that your data can also generalize properly for new set of data. Then number 10, you're going to consider adding more features. And it's really very important because your data is not actual, your model should be adaptable to different changes. And for it to be adaptable to different changes, you're going to add more features. So you can see to it that it can really work best for different situations. So this is what we call a feature engineering, wherein you test the different responses and what could be the the features based on these different responses or labels. So you can infuse different considerations into your training data. So let's say, for example, uh, you have this certain sales data and you would like to add the different customer feedback into your model because um, in the former model you just considered the the sex of your or the gender of your customers, the amount paid, and it the day that they bought in your store. So you can also add customers day the customers feedback as to the mm, okay, as to how they are treated when or accommodated when they buy in your store. Okay.